Forestil dig det her. Det er næsten forkert at starte det her afsnit med netop den sætning. For hvis man kører ud til Odense Havn, det gamle lindeværftet ved Munkebo, så troner der netop nu et stort, hvis ikke et kæmpe byggeri op, som er større end mange af de haller, der allerede findes på havnen. Her bygges nemlig netop nu SDU Large Structure Production Center. Og så er det måske alligevel ikke. For kan man egentlig forestille sig et robotcenter med kraner og robotter, der kan nå flere meter op i hallens afkroge, svejse med millimeters præcision og hjælpe med at bygge kæmpe konstruktioner som vindmøller, bygninger eller skibe? Det kunne SDU-professor og leder af Large Structure Production, Christian Schlette, næsten ikke, da han første gang trådte ind i de bygninger, der inden længe endnu en gang kan sætte Odense på verdenskortet inden for robotteknologi. I dette afsnit fortæller Christian Schlette om historien bag et imponerende bygningsværk, hvor langt de er nået, og giver også en lille tur rundt mellem de kæmpe robotter og kasser, der endnu ikke er pakket ud, men som rummer løsningen på en hel del udfordringer i fremtiden. Mit navn er Louise Holmgaard. Velkommen til Robotterne kommer.
We are working on this for a long time now, and I have seen the plans. I have even done some 3D simulations myself, so that you can, in virtual reality, already walk through the gantry. Still, to see it physically with your own eyes, that's something totally different.
Når dørene til Large Structure Production Center officielt åbner i 2026, vil det være til et syn, mange ikke har set før. Robotcenteret bliver nemlig indtil videre verdens største af sin slags. Inden længe står den store hal færdig, og så kan de første flyttekasser blive pakket ud. I spidsen for det står Christian Schlette, som du også netop hørte her. Han flyttede til Odense fra Tyskland med sin familie for 10 år siden, netop på grund af den viden og det miljø, der findes her inden for robotteknologi. Her får du fortællingen om det kæmpe byggeri, som kan hjælpe med alt fra skibsbygning til offshore og energi-industrien. Det skal lige siges, at interviewet er på engelsk, og på besøget hos Christian Schlette sidder vi både i et mødelokale og går rundt i en stor hal. Så er I forberedt. Men lad os starte med at præsentere dagens hovedperson.
I'm Christian Schlette. I'm a professor at the University of Southern Denmark, SDU, and I'm heading the SDU Center for Large Structure Production, LSP for short. And we wanted to talk a bit about where we are right now, because soon we are going to have the full center in place. And it's going to be exciting then in 26 to open it. But nonetheless, we are already going in projects and with our partners for about 2 to 3 years now. If you drive by, you actually see it also on the way to Kerteminde. It's this big hangar, about 30 meters high, and this is going to host the main piece of our equipment. It's going to be a big robotic workspace with 4 robots. It's 30 meters long, 20 meters wide, 10 meters high. And then since there's a crane and ventilation and all sort of other equipment, it needs to be such a big hall. But it's amazing. Currently it's shining in silver in the sunshine, but there's going to be an additional layer of facade that is going to give it this rusty look that we also have at SDU. So we are very much looking forward to it.
Hvis man kender til robotbranchen og har fulgt med i arbejdet og udviklingen på Fyn, så er det svært at have undgået at høre om LSP og det nye robotcenter. Men hvad er det egentlig? Og hvad skal det bruges til?
So now I mentioned Længe and I mentioned Odense Steel Shipyard, and I think it's very important to us. So organizationally, the SDU Center is part of the Maersk Mc-Kinney Møller Institute. This is part of the tech faculty at SDU. And the name Maersk, of course, rings a bell, and also being here at the Port of Odense has some history behind it. It was early on that when Maersk was building their container ships here at Længe, that they started, I think already in the 1980s, to make use of robots for robotic welding and use of CAD data, so digital models of their ships, to program actions of those robots. So we this is a bit what we are going back to. So when we're going to talk about equipment and what is LSP and what we are going to do with this equipment, then we are currently also contributing to bringing back shipbuilding to Denmark. And this is sort of closing the loop. And then, of course, also it was AP Møllerfonden. They donated the building to us. So that we are, of course, proud and happy to be part of their history and to be part of this history, which is so important to Fyn. And I would even claim it's important to all of the robotics and automation community in Denmark, because that is really one of the roots of this community in robotics. If we today see Universal Robots and Mia and many others in our community in Odense, in all of Denmark, I think Denmark is such a stronghold in robotics because they started so early out here at Længe, or what is today Odense Havn, the industrial port of Odense. This robotic workspace that we are building, to our knowledge, it's the largest robotic workspace worldwide. And for the 15 minutes, and someone else is adding some 20 centimeters left or right? But also we know that this is sort of the state of the art. You can't. We know that only with very big efforts you can build anything that is larger in the dimensions than what we have here, and the precision that we can then achieve with the robots.
And what is it you can build here?
Whatever. So we call it a multi-purpose workspace, multi-robot, multi-purpose workspace. Multi-robots because we have 4 robots that can move all over the space. And we can bring in more robots and cranes and mobile platforms. We can move it into this workspace. And multi-purpose because actually you can put on whatever, it's then called a tool, that we can put on the robots. So you can put on a tool for welding, you can put on tools for painting, you can put on tools for also weird stuff. It doesn't need to be steel as an material. It can be, for example, composite materials. It can be concrete. We have one option where we take off one of the robots and put on what is called an extruder in order to do 3D concrete printing in this workspace. So this is sort of, you can think of it as we can program the robots to do whatever you will find out here in the companies around us, or also all over Denmark and in Europe, whatever they need in their production today in the sectors maritime and construction and energy. So very different operations.
And very flexible.
Very flexible.
Yeah.
Yeah, that's part of it, right? Because if we are going to offer this, so the point is that today it's not so much a discussion about replacing workers with a robot. Maybe that was a discussion some 20, 30 years ago. But today, I think that's also a bit special about Denmark and how we look at robots. It's more about adding robots to the workforce and making the existing workforce stronger and enhance them, basically, with having robots at their side. The main problem of many of the companies here in those sectors is there's not enough workers, right? And they are so highly dependent on manual work, manual labor. If we look at, so around here in Odense we have, for example, Fayard, we have Vestas, we have Seas Wind Offshore. Most of their products, most of their operations are based on manual labor. There's hardly any robots around here today at Odense Port. We are aware of a few robots that are also doing welding. And then there's our own robots, of course, that we know. So it's really more about helping the companies to stay afloat, right? To have their production challenges being taken serious, and then to come up with automated and robotic solutions to actually help them to keep going and to keep this type of production And we can talk a bit about what is so different about this type of production to keep this going in Denmark, in Europe. And we all know the news, of course. We understand that it's important to be able to have the capacity and the competence also to do things like shipbuilding back in Denmark or back in Europe, right? So the geopolitical situation tells us that this is something that we may have offshore to Asia some 20 years ago or sometimes even 10 years ago. But that was something that we need to get back somehow to have some control over our own future, I would say.
Yeah. And why here in Odense and
And this is, of course, due to the history, right? So there is this history that I mentioned with Odense Steel Shipyard, and also the robotics community. So the Danish cluster for robotics, it's called Odense Robotics, for the reason that this has its root here in Odense. And this is always sort of, it was also always an interplay of the needs here at Odense Steel Shipyard, and then the Maersk Mc-Kinney Møller Institute. It was also donated by A.P. Møller and the Maersk Mc-Kinney Møller family to exactly bring this academic and development of robotic solutions to the shipyard. So many of the researchers of the Maersk Institute, they were very much used to be out here and work with the people side by side to look into their issues with, for example, robotic welding. And then when the shipyard closed in 2009 to 2012, many of my colleagues, then even though they had this mindset of doing something directly with industry, the shipyard was closed, and then they were open to new adventures, right? New journeys. And many of them became founders of some of the companies like Mia, for example, that were then also crucial and the basis of the Odense robotics community. So we are going back to where it started. Also, Odense Havn was very successful also in the meantime. So it was first some industrial park, and it's now one of Denmark's most vivid and also valuable industrial production ports. And across Europe, one of the last places where also that can still be grown and encompass larger areas or can invite further tenants to grow their production in this area. And we are then part of Odense Havn's catalog of pros and assets, which can also be then support for the companies immediately, right? To have robotics and automation competences as part of the infrastructure that we have out here at the port.
Yeah, you said earlier that you have been working on this since 2017.
Yeah, that's right.
Yeah.
Yeah.
Why now?
Well, it took so many steps, right? It also, I was probably crying a lot into my pillows in the years or over the years. So my background, so I'm from Germany. I was with the Institute for Robotics Research in Dortmund until I think 2005. That was at that point in time one of the few institutes with robotics in its name. And after that, I was with RWTH Aachen University, which is one of the big engineering universities in Germany. So there I learned to work with robotics and automation and simulation and digital twins, all the methods that we are now also applying here. However, the focus in Germany was very much on the automotive industry, right? So it was always about car manufacturing. My interest was not to bring robots to factories, this we already know, but to take the robots out of the factories. If you look around here, a shipyard, a construction site, this large structure production looks very different. it's not that you have a very clean production line and the parts are moving by in a sort of conveyor, and your robots just can work on it, and then they are pulling back, and then it moves to the next station. You do not want to move a ship around between robots. You have to move the robots across your product, right? So it's also a highly dynamic environment. People are moving around, tools are moving around, materials are moving around. So the robots, if you want to bring a robotic solution, it needs to be way more sturdy in terms of what it can lift, how far it can reach. It needs to be larger by and large. And it needs to be more aware of the situation in order to guarantee the safety of everyone around. So I was interested in construction robotics since 2015. And then I already knew the team here from SDU Robotics, from working together in European projects. And I always liked the mindset, which is in parts very different to the German mindset also. And I was bringing this idea of construction robotics and wanted to get it going. And it was here that also there was an opening for an associate professor back in the day. And I called Henrik Petersen, my former boss at SDU Robotics. And Henrik also, he was very happy about this interest in construction robotics. And of course, this was then mixing and mingling with this history here now in the maritime sector, right, with shipbuilding. And Henrik was actually also one of the people essential back in the day to the operations here.
Det blev starten på LSP og den bygning, der netop har været rejsegilde for på Odense Havn ved Munkebo. Herefter kom Christian Schlette ellers på arbejde for at finde ud af, hvad det præcis skulle indeholde. Og drømmen blev stille og roligt til virkelighed.
And then I was tasked by Henrik Benslow to start thinking about this education center, right? And then in our discussions, we came to scale it up. I had some inspiration also. There's some other institutions like in ETH Zurich, for example. They also have a gantry, a smaller gantry, by the way, but they have a gantry that was very much prominent, and I knew it from the perspective of construction robotics that this can be very useful to have such a equipment that you can work with. And then the idea was growing from there, and we approached the companies. I was talking to Fayard for the first time, meeting the guys from Odense for the first time, and also Blad Industries, so what is now Sears Wind Offshore, talking to them, and they said, we like the idea, however, we do not have any money that we can invest in it. And then there was quite a disappointment because everyone agreed that's a good idea, but there was no money to get it started. Someone has to take this initial equipment investment into the equipment. And it took some time and also more and smaller projects along the way. And then we had the opportunity with the Erwerbsfürtorne, the industrial lighthouses, where we then received. So we were handing in this idea with building this center, and we received then the funds to actually make the investments into the equipment. Then came the donation for the building, and altogether, this was then the starting point of what we are looking at today, what is now established as LSP.
You talked earlier about shipbuilding in Denmark. How can the LSP Center and the Robot Center help in and do any like work in that sense?
Yeah. It's a really good question. But from the beginning, when we were planning the equipment of this multi-robot, multi-purpose gantry system, and also the crane that we talked about, and this is taking ideas that are around also in this area in shipbuilding since the 1980s or 1990s. We are just bringing it up to the latest state of the art. Right, and we are taking in the latest in sensor technologies robot technologies, also programming and software, and AI even. So this huge workspace, it was from the beginning designed to also help with robotic welding. If you look into robotic welding, how it's done today at shipyards, and how it's done actually since the 1980s, and later was a front runner, and then they also taught other shipyards in Germany and Korea and Japan what to do and how to do it. It is very much something that is two-dimensional, right? You have plates that come together, and then you have a robot often from top that comes in order to do the welding. With this new gantry, we want to actually go into 3 dimensions. So not only to join plates by welding, but to build full compartments. So 3D structures where we then come from top, from the side, where we can flip it around in order to have further access for the robots. So that we can actually maybe in maximum can have all 4 robots doing welding jobs in this 3D structure. And this is crucial for bringing back shipbuilding to Denmark, because if we look today, even though the Danish maritime sector is the 7th largest in the world, we can be proud of that. We also, over the years since the shipyards closed down, also drifted a bit towards being more specialists in components, parts that go into a ship, equipment, technical equipment, and outfitting. So often the hull for a ship that is built in Denmark today is not built in Denmark at all. The hull comes from a different place where it's today cheaper to do the steel welding job of putting together a hull. And then the Danish shipyards, they engage in often repairs and maintenance, or if it's a new build of a ship, they do then outfitting. So this is to take the technical equipment and take the different parts of a hull and assemble it into the full ship, right? And then this is the specialty of the shipyards today. But with this gantry system that we develop, and we develop it really since several years, even before LSP started with companies such as Odense Maritime Technologies and Inrotech, we started working on this topic in 2018 to discuss it and then to have a project on it in 2019. It's very much also about the data, how data is processed in order to have automatic processing with robots on a ship design that you have as a digital model. And then to actually use the gantry to do this welding job that is currently so expensive and where we do not have enough people also to do this. It would be very expensive to do this based on welders in Denmark today. This is also the reason why it was shut down, for example, at Odense Sea Shipyard, because to build container ships in Japan and Korea was just cheaper for Maersk than doing it out here. But there, robotics and automation can help to become a crucial component, even though if this is still expensive, you have to have the investments into the robotics, and you have to still have operators around who can manage it. It's important for some crucial technologies, critical infrastructure, that we in Denmark or we in Europe can build a frigate or additions to the Navy and other structures that are critical for us without being dependent on others that are outside of Denmark, outside of Europe, and may not have the capacity, or maybe may even have a conflict of interest to deliver those structures to us. So I'm very proud that we can contribute to this critical discussion. And yeah, as we talked about geopolitical situation, it's also crucial right now. There's more people understanding that this is actually very important to reshore, to bring back some of those competences and capacities in terms of production capacities back to Europe, back to Denmark. And it's just today we wouldn't do it in the same way. We don't have enough people that engage in what we sometimes call 3D work, dirty, dangerous. And we take whoever is interested and we open it up with robotics and automation to have also more and different people around. Welders can be upskilled to become operators for robotic welding. Their expertise is still wanted and desired and necessary. But we can also take in engineers. We can have basically also more women taking part in those operations, because you do not need to have the strength and physical power anymore to operate a robot. It's more about being there, being present, being aware, knowing a bit about robotics. So I think there we are going to see a transition over the next years. And the lighthouse, in the context of next-gen robotics, has this as a focus to also think about shipbuilding and the tradition of Fyn, but also in Denmark in general, closer. So it's a network of partners that are working together.
Yeah, so it's very unique what
Yeah,
you
it is.
have
And
here.
also we get a lot of requests from external. So it's due to the outreach of OMT, of Odense Maritime Technologies. So they are also having their designs built worldwide with the NATO, for example, in the UK or in the US and in Australia. But we can see that they also based a lot of it on the ideas of Linux. And now people are coming to us together with OMT to also learn about, okay, where's this going to go now with the new robotic technologies? Can we also make use of this? So it may be that this what we have as a unique solution that we understand first and foremost ourselves, but then also to export it to other partners in Europe, in the Nordic countries, in the Baltic, around the Baltic countries, also within NATO, to other partners who are interested to also make use of this technology, of this Danish technology.
I dag arbejder Christian og hans medarbejdere i midlertidige bygninger på Odense Havn, indtil de nye bygninger står færdige. Det er også her, de første robotter allerede er pakket ud og trukket i arbejdstøjet. Nu skal I med på en lille guided rundvisning mellem de store robotter og trækasser. Og det første, vi kom forbi, var en stor robotarm, som måske lyder genkendende for mange, men så alligevel ikke.
This one here, what we're looking at is a big industrial robot. It stands on a concrete socket that is about 2 by 2 meter, and which already gives an idea of the forces and torques that this robot can actually excite. The robot has a reach of 3 meter, even a bit more. So if it's all stretched out, it can go 3 meters in all directions. And here on top, you see that there's a plate to which we can then mount different tools. As I just mentioned, with this multi-purpose approach, we can take a welding gun for robots and screw it on top of the robot or whatever other tool. And the robot can transport up to 210 kilos of payload. So this is a lot, right? This is enough to have many different tools and to be safe to actually also attach some sensors and some additional equipment around it. This robot here is the 5th robot. We have 5 robots of this type. This one you see mounted to the floor. And then we are going to see 4 other robots. Those are the robots that go into the gantry. Same type, exactly the same type. But they are hanging in a sort of cage because they are what is called calibrated for upside down operation. They know that they are going to work upside down in their lifetime, right? This one is mounted to the floor and calibrated differently. But we use this robot here, and we stay in a cage here, so there's fences all around us in order to make this a safe workplace. We are using the robot here to start what I mentioned with the cabling and with the programming of this robot, so that when we have the gantry installed, can hang the 4 robots from it and can just take whatever we have developed for this robot and bring it over and get going with the gantry. And if you turn around, there's 2 smaller robots also, 2 robot arms. They're way smaller. I think they're good for 10 kilo or so of payload, but also industrial robots. So they are programmed exactly the same as the big robot here. and they are carrying some funny things. So one has a coordinate system up here, and the other one is carrying some sensor type. And just behind you, we have a laser scanner that is tracking this, what is mounted there as a reflector on the one robot. And we are starting to look into, this is equipment that goes into the gantry as well. We are starting to look into this laser scanner to be able to take the data and to use the data to move another robot. So when the one robot with a reflector mounted on it is moving, then we are tracking it and we are using this information that we got from the sensor to actually move the other robot accordingly. So that the distance between the two is always the same. This is the first step to actually have this very same laser system being mounted in the gantry. I told you it's a large workspace. We have 4 of those lasers tracking our robots. The gantry is so big that even though it's massive steel, right, and concrete, it's still going to bulge a bit. So it's going to come down a bit. There's going to be a displacement due to the sheer weight of the gantry itself, and then the robots and their dynamics. We know that the robots are going to be off by 1 to 2 centimeters of where they are supposed to be in this workspace of 30 meters, 20 meters by 10 meters. So it seems to be small. But if you want to do welding, 2 meters off means that something is wrong, right? And this laser scanner system is going to allow us to position then the robots by correcting their motions and measuring where they are, and then correcting it to a sub-millimeter range. So it's going to be highly precise then over all of the workspace.
Okay. And what are you using these robots and the lab for now?
It's called commissioning. So you see in the background all the boxes. We are opening the boxes. We are taking all this equipment. We see that all pieces are in place and that we can communicate with it in terms of cabling, in terms of programming, and that we are then ready to bring it over to the new building and put it in place and already can start with working with it immediately. This is what we did over the last 2 years, basically, here in this temporary facility. So we were working on some projects with partners. We were working on our own preparations for the center building being ready. And we also, and this is then the next hall that we are going to see, we used it for storage because this equipment, we were buying it, finalizing all purchases 2.5 years ago, and we had to put this somewhere until the building is ready. And this is the one of the reasons for this temporary facility.
And all of these things are just waiting.
Some of it is going to wait until we have the full building. Like, for example, you see here a set of cleaning machines.
Yeah.
The hall here is small enough that we can just clean it with a broom. But this is then in the big building, in the big workspace. You do not want to do it just manually. And this is where we have those sit-on cleaning machines to move around. So here we're now out of the fence again.
Yeah.
And we are standing in front of shelves along the one wall here. And on the shelf we have pallets and boxes and crates. And this is the smaller equipment parts that we bought from the funds that we received as part of Erhvervsförderung Fyn and the first call. So you see those boxes here with a orange logo on it. This is more parts for robots. It's even more robots in some of the boxes and control boxes and cables and motors for the gantry. Over here, up there, you see what is called an extruder for 3D concrete printing. So you would have to imagine it upside down, and then it's like an opening, and we are pressing concrete through it. And then concrete is then healing, so it's becoming hard. And we are then moving this extruder around and then lifting it up a bit. And so we can print layer by layer, like a 3D printer really, of concrete. And further down, you see control cabinets waiting to be installed on the gantry. You see welding equipment. So this is then tools that go into the gantry to help us with robotic welding and robotic painting. Those wooden crates, we have grippers, for example, that are not small grippers like you may have seen them on top of a universal robot. But they are huge, right? So right behind me, we are looking at some robotic mobile platform. This is 3 meters long and 2 meters wide, so it's already quite big.
Yeah.
And we can transport 12 tons on top of it. So it's
A lot.
that's a lot. And we have some smaller platforms over there. But this is, for example, to also bring parts into the work cell, into our gantry, and to take it out again. So helping with the other aspects of the automation. You see that this mobile platform has some funny wheels. It's called OmniMove wheels. So actually this platform can also drive sideways. And we can turn it on the spot and so on. So this is why it looks a bit funny with the wheel constellation. Then we go further. There's another robot. We look at also an industrial robot, just a bit smaller than the robot we have just talked about. It's all black. Code name of this robot is Black Beauty. This is a robot that we are going to mount on our crane soon. And we are going to see our mobile crane, and I will explain it a bit further. But just imagine this robot here. It's a huge robot, right?
Yeah.
And we are going to mount it on a boom crane, on a regular crane, as you've seen it around, in order to not only have the gantry, but also a mobile solution to move around and stretch out, and then have robotic welding operations at heights of 20 meters or 25 meters. So
Okay. Yeah.
wild things.
It is.
Yeah.
And it's all very big.
Yeah.
It's like a huge.
Absolutely. Yes. I mean, we also work with, for example, smaller robots, universal robots. But we have, there was a project where we, for example, had a pair of universal robots for doing assembly. But as I mentioned, if we want to carry around 200 kilos of tools, and sensors, then suddenly you need to bring a big robot in order to be able to move it in space with high precision. Now we walked over to the next hall.
Big hall.
It's a big hall. Around us we have wooden crates and boxes that are higher than we are.
Yeah.
Longer and bigger. In those boxes we have the pieces of our gantry. So all the metal parts, the machine elements of the gantry are in here. And now in autumn, the new LSP Center building is going to be far enough that we are going to take those boxes, open them for the first time. Actually, we know what's in them. So all the boxes have photos attached to them to show what's in there. But they were basically packed 2.5 years ago, and we are now going to open them for the first time, take out the parts, and mount it directly into the gantry. This box that we are standing in front of, this is, I would say, it's 2.50 meters high, 2.50 meters wide, and then 8 meters in that direction. This is containing 4 towers, 4 steel structures from which the robots are going to hang them. So this is the towers that allow us to move the robots up and down for 10 meters. So in this box we have 17 tons of material.
Okay.
Just dimensions and weights are very different when it comes to large structure production.
Yeah.
It's important for us that the new building, the hall, we asked them to finish this first, so that we can also in the background already work and start with the gantry. There's already 2 rows of concrete columns, and we are going together with Güdel, one of our suppliers, with Inrotec, another supplier, in KUKA. We are going to do the installation then, take the part of the gantry and mount it into this concrete structure and into the hall. This is going to happen in autumn. In winter, we are going to pull cables all over the place. There's many kilometers of cables necessary in order to contact all the motors and have power to all the motors. And then in March next year, the building is going to be finished, inside and outside, and also the administration, so the offices we have, so that in principle we can move in. And then there's some preparations that we take in order to have some grand opening event in June next year. And this is then when we have LSP fully in place, right?
And now we've moved further into the
It's
the
a
deep of the whole.
exactly. It's a maze of boxes, and we have we now stand in one opening in the center of this hall. We actually have some more crates and some more equipment, but this is not stored here. It's stored in Odense Dryport in Oslo. Because this just needs to sit somewhere, and it's huge. But we wanted to make use of this space. As you can see, we are standing in front of a crane. It's a bit of a special crane. So on top we have a normal boom crane, so a crane arm, as you would find it on mounted on vehicles. It's around here a lot, here from our supplier Palfinger. But this crane is a bit special. If you look deeper, you see it's coming on tracks, so it can be moved around. It's a mobile crane platform. But when you buy such a crane, then it's operated manually, right? So you have one guy with a sort of control box in front of him or her, and then there's joysticks on top, and you have to have a crane license then to move around this crane safely to mostly lift and transport items with it. We have this crane. I mentioned it already that we are going to mount this larger robot on top of it, and we have already done it.
Mhm.
So this is now folded into parking position. But if we stretch out the crane, we can easily reach all corners of this hall. So we can reach out 15 meters, 20 meters, 25 meters, no problem. And then imagine to have a robot on top of this, and then a tool like a welding gun on top of the robot, as we just talked about with a other robot. And then you can actually do welding operations up there in the corner without what would be necessary today to have some sort of scaffold or to put a man in a basket and lift some person up there in order to do the same job. You can program the robot to do this job.
Yeah.
And this is what we do together with Palfinger and other partners, that we convert this manual control today into an automated programmable control. You see this cable that is going to the computers, and in the computer we have a model of the crane, we have a model of this hall here, and then we can program the crane like we would program a robot. So actually the crane becomes a robot. We can program it, we can move it around, and we can add sensors to it so that it doesn't collide or get in contact with the surroundings. And then we put a robot on it that we can also program, and a welding gun on it that we can also program. And then we have a mobile platform with a robot arm on it. But this robot arm is then on this boom crane, and all can be programmed also for semi-automatic, so only half of automatic operations. You would still need to move it around between places. But maybe we are also working on this in the future.
Yeah, and it's hard to imagine, I guess, if you can't see the crane, because it's folded down, but when you say it can reach to the corner, like the corner that's pretty far.
Yeah, it is. It is. Yeah. It's folded down, and also it's stacked, right? So if you move it out, then the parts come out one by one.
Yeah.
And this gives us the reach that we have. But even now, since we are speaking, I'm standing next to it.
Yeah.
And this is, I think, 5-6 meters to get to the other end. And it's 3.50 meters high.
Yeah.
So it's big already, right? So you can imagine that this is possible then if we fold it out to reach the different corners. This is a project where also SES Wind Offshore, or formerly Blad Industries, was involved, because they sometimes have in the monopile production cases where they want to inspect something or fix a bit with a painting, with a corrosion protection. And usually today, someone would drive up with a similar crane, but in a basket, and then do the job manually. But that's very expensive. And then if we can offer such a solution that you can use in your production for really making new parts as well as for maintenance and repairs, then this is where Cis Wind Offshore was interested to join this project.
So this can be used for building these components for windmills, houses, offshore.
We have several projects on this crane. So one project is about the operations for wind energy, so of the production of Cis Wind Offshore. We talked to, for example, Største, and they said, okay, well, they can imagine to make use of this crane when it's a bit further or closer to be a product for welding operations. It's outdoor capable, right? I wouldn't mind to also take it around, whatever the weather is. We have talked with other partners, for example, Fayard, that this could also be a platform to work on the hulls for ship repairs, so to bring it to the docks. We have talked with other partners to bring the crane to construction sites and have operations then with this. So we started out with one idea, but we can see how this is now, actually steering interest in many different sectors. And this is what we also want with the center and with the gantry. We often see that other organizations or other labs in Europe or worldwide who have maybe something to do with the construction industry or maritime industry, they often focus on one industrial sector alone. Construction, maritime, or maybe on materials alone, concrete, or we only do steel, or we only do composites. And we go across all of it, and we step back and say, well, isn't it the robotics and automation that we're interested in? And then we can apply it across different materials and across different industrial sectors.
So many can use this, and it can benefit their company, their work, their products.
Yes. And we built sort of a platform where we have many technologies available, where we understand many of the technologies that we can then recombine to new systems and solutions for the partners. And you mentioned it's hard to imagine. One of the listeners is invited to also reach out to come and visit us, or to get a presentation in an online meeting first to learn more about what we are talking about here and to get an impression if this could be something that is of interest for them as well. And it doesn't need to be a big company, right? We are also open to work with SMEs. We are open to work with also not only Danish companies, can also be European companies or worldwide, basically. And this is, we have something here in Denmark, here on Fyn, here at Odense Havn, that is unique, and it's globally unique. I know from being around in this area for many years that this equipment, this center, also this team of really smart people that I'm happy to have here around at the center. Also our industry partners, our suppliers, this network of partners and friends, it's like a family, sometimes also like a family out here at Odense Port, that we have this very unique history and this very unique also moment in time, that this center is landing in just the right point in time. And I think, I hope that in particular Denmark will make good use of it.
It's going to be so exciting to follow the next.
We are certainly excited.
Yeah. Thank you, Christian, for the
Thanks
tour
for the visit.
and for the talk.
Yeah, you're welcome.
Robotterne kommer er udgivet af Erhvervshuset Fyn og Next Gen Robotics. Det er medfinansieret af EU og Danmarks Erhvervsfremmebestyrelse. Tak fordi du lyttede med.